Hey everybody. So this is just a little tutorial about developing a prism. So, you'll see here you've got a little item for you to go and open this PDF file to work along with me, but it is also in the book on page 388. But this is a pretty straightforward concept that you will be applying to, well, just about everything you do. uh, this is the crude concept of what sheet metal is like. So, we're taking like objects with no bend radii and making them flat. So if you were to go and take something like this and take every face and remove them and make this all just one flat piece, kind of like you see here, you could print this off on a piece of paper, cut it up and fold it, and you could make this shape. And that's kind of the concept. That's a development. A development is taking a 3D object shape and flattening it out for the intent of design. So a lot of times, later on down the road, you'll have sheet metal. You could actually have a sheet metal assembly like this. If you were to envision a hole going through this, you could actually make something like this. And you would go about that by having a flat pattern. So this is kind of, leading into what we will be doing with sheet metal later. But essentially what you do is, like it shows here, you start with your front and top view, and then you do a normal auxiliary view like you've done in the past, but then you have to go and think about your faces. So you can kind of tell it's got it labeled here. What they've essentially done is they started at 1 and went around clockwise and did the offset values of each of the distances, from like D to A, A to B, B to C, and so on until they got all the way through back to point 1. And then they just simply project over, and that gives them the heights and what to connect to what. And then the auxiliary view that you did is actually what they use to make that final face like this. And you just pretty much put it on the spot where it goes, and each vertex lines up. And that's kind of why you also label it too. Is because it's pretty easy to lose track of what you're looking at. But if you put A on each thing that has A, well, when you get to the point where you're trying to figure out where things go, you know where A is, and vice versa. A here connects there. So labeling does help. On these first few assignments, they're really not, too hard to figure out without, you could actually avoid using this method altogether, but it's good to get in the habit because, this will be the way you do this at times with 2D stuff. Really, though, sheet metal stuff you typically see is done in 3D, so it's a completely different process then. But for what we're doing, I'll give a demonstration. And, as always, you've got your DWFs to work with. Let me just fire up AutoCAD. Okay, so I'm going to do the last one for this lab just so it's not, too simple, because we have one kind of similar, but, it's kind of low hanging fruit. Like you could figure that out on your own. In fact, that's the same as the example, I'm pretty sure. Yeah, so I mean, that one you have right there. So we're going to do this one, and it is metric. And let's get a B size sheet. Okay. So now we've got ortho on. I'll just go ahead and draw my lines like normal. Well, I drew this line up here. Okay. Turns out this is a little bit bigger than I thought it would be, so I'm going to move it down. And we will do an offset command with through. I'm going to go with like 120. Do another offset. Sorry about that. Okay, so I'm just basically going through and offsetting everything here to get us in the right spot. then I'll trim away. And there's a shape. So I'll project this down. Naturally, you know, you're pretty proficient with this, so I'm not bothering to waste too much time on it, but you know, you know how to do this kind of stuff, the basic projection and whatnot. Move it down a little more. And I'll move, oops, I won't erase it. I did it twice. I'll move this up about 10 more. Okay, so the concept of where to start is kind of whatever. I still like to use through for everything and kind of do it by eye. So I'll start at 60 as my base point, and I'll make this a different color just so I know what I'm looking at. Now, I did fail to mention it. Wait for it. So the reason that they do this part and they go clockwise is so that everybody's on the same page. So you should also be starting in the top right corner like that and working around clockwise. And a big premise of that is, so you know, when you're looking at a part like this, it's laying flat, and you know that the first edge is here, so it's going to all be folding in this way. You know, so like this edge folds in, then this one folds in, this one folds in, and then finally at the very end, as you fold this last bend here, or here, this piece would connect to that piece. And that's kind of to simulate sheet metal, because when you're thinking of sheet metal, when it's being actually formed, it can only typically be formed one direction, you know, up. So this is, you know, that's why they chose to do it there, is because of the way that sheet metal is bent, unbent. This is easiest for the manufacturer to know what they're looking at. So keep in mind, you do want to do that same spacing and start with this top right corner. So, you know, I'm not going to bother to do the labeling, but you could on some of these if you wanted to label the vertexes A, B, C, and D. You could. Oh, sorry about that. That is my phone. Turn that down. Okay. So anyway, I'm not going to label those. I'll let y'all, but I am going to just throw in some random dimensions for my own viewing benefit as I do some offsets around. Okay. So we know that we're starting in this top corner here, so I need to do a value of 20 for the first offset. And then we're going to do two 28 offsets in a row. And we're going to do it from each line to the next, which is why you see so many dimensions over here. So we've got 40. And then finally, oop, that was not 56. Finally, 56. Unfortunately, it looks like a C-size sheet would have been a little bit better, but we'll just kind of cram it all in. You know, I would suggest using a bigger template, needless to say. But I can go ahead and connect the bottom ends all together, since we know that, you know, naturally they're all going to be the same edge. Put this on the correct layer. And now we can just go ahead and project off the page. I need to extend all of these. All right. Let's trim. Okay, so when we're looking at this, you know, and this is where the 3D model does help a little bit. So we know that from here to here is this face over here. So we know that it is short, because, you know, if you're aligning this this set of vertexes and this edge, you can see that the only thing that is over here is here. So you know that this vertex and this vertex share the same height, and that height is the shortest value. So I will go ahead and trim off these to make it a little more clear. And that's our first face. Now that isn't a bad thing to label, so that's what I'm going to do. I don't want all those edges because I can kind of make it up my own as I go, but I do need these guys. Now we know A and A. So looking at B in this case, we know that this edge and this edge are the endings for that face right here. So that means that it's going to be this height on the far end and this height on the close end. So I can essentially just connect the dot here from here to here at that intersection. And we can trim off a little more. So now, you kind of just know by looking, but essentially we have this bit, and you may think to yourself that it's slanted here, but it's not going to be, because you're not seeing this middle face right here in this next one, which is why I tried to dimension everything as I went. I missed a little bit here. So this one right here would be our next face, this when it's 20 wide, and it isn't slanted. It's the breaking point right here. So essentially we will just trim off this bit. And then next we have, what is the face right here. So we know that it will start on the short end and ramp up to the tall end. So, essentially, I'm not sure that I nailed that. Essentially, you're really just visualizing this and thinking of what each face looks like. And with your 3D model that you have, you don't even have to really think too much about the visualization part. But the entire premise is, that basically you're trying to, you're thinking of each face as it should look, and then nailing the heights and the widths based on projection. And conveniently, the next one is just this 40 wide rectangle on the back. It'd be this back face that we're not seeing. And I might have missed an offset here. I'm just gonna check. Yeah, I think what happened was I accidentally offsetted that one from the pass line. So let's go ahead and do that offset from here to here for 40, and then from here to here for 56. Okay. So anyway, so we know that this rectangular face is just a rectangle, maximum height. So pretty straightforward. And then we know that for this one, obviously, since we're here at this point in progression, because you have to follow along, the extents of each shape, we know that we're going to be here to start, and we have to end over here in this corner. So essentially, it will be the same height as this edge here, which it will connect to. So we know to draw from here to here. Okay. Just trim away this stuff. And I like to keep stuff like these projection edges here. So I'm gonna just break them at its point. And we'll put these on a projection layer. Okay, so we're missing some stuff still. Naturally, we have all of the faces around the part, but what we don't have is this face itself, the actual oblique face, and the bottom face. Naturally, the easiest thing to do for the bottom face is just to copy. Well, let me delete these dimensions. I'm not going to keep these. So we'll copy it. And didn't mean to grab that A. What we're looking for is the face that is 56 wide, because that is where this is from. And we know that this one is 56 wide. And unfortunately, I need a bigger title block. So let me just go ahead and open up a new one, and I'll paste it over. We're in that unmanageable territory. Okay, so I'm just going to copy all this, Control C, and paste it. Now I've got some working area. Okay, so I mentioned, it's got to match the edges. Naturally, this whole part, the bottom face, has to equal the dimension of the folded part it's touching. So now that you're looking at it a little bit better, you can kind of see, the width of this area matches the width here. This width matches this width. This one matches this one. This matches that. This matches this one. And then, the end over there. Turns out I didn't need the labeling. But you know, so the only thing we're missing now is that oblique face, and for that we'll do the auxiliary view. So let's do 60. And the width of this face is the width of this, which is 40. And then for here to here is 20. So we'll do 20 over, conveniently in the middle. And we're not trying to draw the whole thing. We're just getting this face, so we don't need to go any further. I can just box it out. And then we just need to have this one projection line. So I'm just going to right click and do a snap override and choose perpendicular. And I'll extend it because I should have went to the other end. And then naturally we know, you know, this part is the part that's missing, so we can just trim out this bit. And then we'll do the break. Now I do suggest keeping, you know, this face here. It's always more convenient in case it's wrong. Also, it's easier for me to grade, so can't hurt. And then I'm gonna paste this over here. Now there's a couple of ways to go about this, because you know, technically you can't just move this over here because these edges don't line up. So technically I could mirror this and move it over here. I could also, as long as it's aligned to whatever, you've got quite a few options. You could do like a rotate and do a reference, choose here to here, and then I could, you know, make it vertical. And then that would work. The problem is even then you still have to mirror it. So, you know, for it to go up here, but I think that's what I'm actually going to do is I'll move it over, do a mirror, I'll delete the original, and bam. So essentially what you have is, you know, like when you're looking at this, this would be like the one to visualize best. It's like the starting piece that you're going to hold. You would fold this inward, that rotates this into place, and you have that L shape cut out. This folds down, this folds in, that folds in, that folds in, and you end up with the 3D object, which I will pull up just to show. Any minute now. But it's a pretty straightforward concept. You know, as long as you're visualizing it as faces, you know, you'll see that it's pretty darn achievable. It's a basic part, but you know, when you're actually looking at it, as long as you think like I got to draw this face, then this one, this one, this one, this one, this one, and you're just like checking it off, you know, you're generally pretty good to go. And I've talked about it before, but you can also use the snipping tool, catch a screenshot, and kind of go in there and, you know, do your faces as you're thinking about it if you need to. That usually helps me out as a visual aid. That's pretty much the gist of it. So if anybody's having any questions about this concept, just let me know.